viewers, welcome to Science Spectrum with Don. So this will be the third part of the third lecture in trigonometry. So we start off, okay, with talking about the two system of units, okay, that's the sexagesimal and the centesimal unit for angle measure. And of course we talked about conversion and interconversion, okay, between these units. And of course now we will proceed from where we stopped in the second example, right? That is, we are converting 15 degree, 54 minutes, 24 seconds to, the first part is in, okay, to degree, the second is in radian, and the C, okay, degree. So I actually paused the video, okay, or I stopped there to, okay, continue from the next one. All right, so let's proceed on solution. So I'm converting 54 degree, 50 minutes and 24 seconds, okay, to degree. Now clearly I have a degree, okay, to start with. So all I need to do is to convert 50 minutes, 24 seconds, okay, to degree. So 50 minutes, right, to degree. I do know that 60 minutes is equivalent to 1 degree. Acoustic in the times here. So it turns out to be that degree will cancel out, just like, okay, my units will cancel out. Then, of course, I lose the 0. 5 times 1 becomes a 5. R over 6, and this is in degree. And of course, when I punch this, 5 over 6 to get its equivalent in decimal, this turns out to be 0.83. The 3 repeats, okay, so I could just, okay, the 3 repeats. Then this is the first part. So I will add this now, right, to this, because this would be in degree. Is that correct? Let me delete this. So this would be in degree. Now I'm taking 24 seconds now, okay, to degree also. So I do know that now before I get to degree, I know that 60 seconds rather is equivalent to 1 minute. So our last minute degree, okay, that's second, okay, we'll delete out the second. But I still need to go a step further. I have to convert from degree, from minute now to degree. So the intermediate step between second and degree is the minute, right? So I do know that 60 minutes is equivalent to 1 degree, right? So there's a time in between here. So I wrote 60 minutes, or 60 minutes, yeah, is 1 degree. So I lose the minute now. And all I need to do is just to multiply out, right? So when I multiply out, 24 times 1 times 1 gives me the 24. Of course, then 6 times 6 is 36. And I could stick in the 2 zeros here. And of course, everything now boils down to be in degree. So I can just get the value in decimal. And that's 24 divided by 3,600. This is 1 out of 150. And that's exactly given 6.6, let me just say 67 times 10 raised to the power minus 3. So this is in degree. So what minus 3 simply implies is the decimal point, this decimal point will go 3 places backwards. That's what this term represents. So we go 1, 2, 3. The decimal point leaves here, okay, and comes here. So I will stick in the 0 here. So this comes out to be 0.00667, right? And this is in degree. It's the same as this, okay? Expressed in decimal. All right, so now to get the answer now, so this question, a quick one. This would be 54 degree, and of course the equivalent of 50 minutes in degree, we got 0.83. This is plus 0.83 degree, right? Plus the equivalent of 24 seconds to degree is just that. That's 0.00667 degree. So all I need to do, okay, is just to add up the values, and I'll leave the answer, okay, in degree. So I have a 54 plus 0.83 plus 0.00667 Yeah. And of course, and this is the same as just say, so everything boils down to be 54.83667, and of course, this is in degree. So this is, okay, I've converted this to degree. Now, the next step, and this is the A part of the question, the next phase, the B part now, is just to convert this given value in degree to rad, and then, okay, the other parts, the C part should be to convert to grade. So, just a quick one. Now, this is the pair of equivalent statement, okay? I did not repeat this twice. So, you're free to also use 360 degree with amount to, okay, 400 grade, and that is, okay, 2 pi rad. Any of these pair is fine. Alright, so let's proceed. Let's proceed. Alright, so the B part now is I'm converting 54.83667 degree, I'm converting to rad. So I know that 54.83383,667 degree. Now I know that I'm going to use 90, okay? Or let me use let me use pi. Okay? I know that 180 degree is equivalent to pi rad. Of course, I could have used 90, okay, and this will boil down to be pi over 2 rad. So I lose the degree and there's a times in between. So all I need to do is just, okay, to divide this term by this. So this comes out to be 54.83667 over 180, and I have, okay, this in pi rad. And of course, if you want, you may want to replace the pi, okay, with some 3, okay, by 3.142. So let's see. I have 54.83667, 83667, and I'm dividing this by 180. So this comes out to be 0.3046. Let me leave this to 4 decimal places, okay? Then I have the pi. You can just say pi is just, okay, a magic number 3.142. So I'll multiply this now, 0.3046 points. 0.3046 times 3.142. Alright, this turns out to be, this is times 3.142, this is in rad. And of course, this turns out to be 0.9571 rad. This is to 4, okay? Decimal place, and of course to 4 significant figures, okay? So this is to 4, this is to 4 sig figs, okay? 4 significant figures. Alright, now, what the next step now is just to convert this value in rad to grade. So I need to rub this part off, right? I need to rub this part off. We need to build this for a while, okay? So the C part now, the C parts turns out to be, we are converting 0.9571 in rad. We are converting this to grade. So grade is our desired unit in this case. Alright, show this mark. Alright, so 0.9571 rad. Of course, I know that pi over 2 rad, okay, is equivalent to 100 grades. Okay, 100 grades. Right, so this 2 down will come up here. How? I have 100 over 1 is as good as say 100, right? I have a division sign here, and I have pi over 2 down. You can't divide this pair of ratio with another, but you can multiply. So when you do that, it turns out to be 100 over 1. Division sign changes to time, then I can flip the second pair of ratio now, so I have 2 over pi. So that is the reason why I said the 2 comes here, because okay, you have 2 times 100 up there. So there's a times here meanwhile, so this is 0.9571. Of course, I lose the rad, right? Did I use the unit there? Yes. Then times 2 times 100, okay? of course, over pi, which is 3.142, and this will be in Greek, okay? So I need not take this step further, okay? We punch in the values, okay? And write the final answer. All right, so this is just the fundamentals of how we convert and interconvert, okay, between the sexagesimal system or units to the centesimal unit. All right, so let's now go a step further now, okay, to trigonometry, that's triangles proper. All right, and we need to rub this part. Oh, have you built this? All right. So let me talk about briefly units, circles, and basic trigonometrical ratios or functions. Okay? So I'll start off with basic trig ratios. Okay? And also I'll talk about unit circles. Unit circle. Okay? Alright. Alright. Okay, so let's start with let me start with a unit circle. Okay? So if I have a circle like so, right, they're not properly drawn, and this is okay, the center of the circle, right? Now, if I define this to be the radius, the line from the center touching any point on the circumference of the circle, right? We call this the radius, right? Okay, now watch this. If I now draw the coordinate system, that's the Cartesian plane coordinate system, this is my plus y axis, this is the negative y axis, this is the plus x, and this is okay, the negative x axis, and of course we have the origin here, right at the center of the circle. Now, a unit circle is simply a circle, okay, whose radius is just 1 unit. So if I make the radius here 1 unit, 1 unit, okay, I make this radius 1 unit. This is how we define a unit circle. So we could say a unit circle is a circle whose radius, okay, or we use the word radii now since okay we have lots of them, is 1 unit. That's a unit circle. Alright. Now I will need to rub this part off now. So I will relate the basic trig ratios now to the unit circle. So I need to rub this part off. Okay. Alright. Alright. Okay. So let's start off with the basic trig ratios. The basic trig ratios. There are 6 of them. Okay, starting from SOHCAHTOA, right? And of course the inverse of this, okay, of SOHCAHTOA. So this represents sine of an acute angle. So if you have a right angle triangle like so, you are free to imagine, okay, a right angle triangle like so. This right angle triangle, 90 degree here, right? And if you are free to imagine, okay, this to be the acute angle of the right angle triangle. So what it implies is this angle has to be 90 degree minus, okay, the value of this. So we have a right angle triangle like so now. And for my convenience, okay, I prefer to use this as my acute angle. Of course, I could have used this, but let me use this, okay, for my convenience. So the sine, that's S now, the sine, right? But we abbreviate that with SIN of this acute angle, right? Is simply the ratio of the opposite side. And what's the opposite side? The opposite side is where the acute angle is facing. Acute angle, the angle is less than 90 degrees, right? So this is the opposite side. Opposite side. And where the 90 degree angle is facing, that is the hypotenuse side. Hypotenuse side. And of course, this is the adjacent side, okay? The adjacent side. Alright, so the sine of an acute angle in the right angle triangle is simply the ratio of the opposite side to the hypotenuse side, right? Then the same goes with the cosine, okay, of this acute angle in the right angle triangle given is the adjacent side over the hypotenuse side. So this is the adjacent side, the adjacent over the hypotenuse side. Then we have T's for tangent. So the tangent of this acute angle is simply the opposite side over the adjacent side, is the opposite side over the adjacent side. And of course, it could also be the ratio of the sine, this pair, over the cosine. Okay? So if you divide opposite over hypotenuse by adjacent over hypotenuse, right? Clearly, you can't divide two pairs of ratios, but you could multiply and flip the second pair of ratios. So I'll use the hypotenuse side, and of course I'm left with the opposite over adjacent side, which is the same as the tangent, right? Now then, you could take the inverse, okay? We have the inverse of the sine, okay? The inverse of the sine, the inverse of the sine, okay? The inverse of the sine of this acute angle, we call that, okay, cosec theta, cosec, okay? That's cosecant in full. Then when you take the inverse of the cosine of this angle, right, you get sec theta, that's secant in full. Then when you take the inverse of the tangent of this angle, right, it turns out to be cotangent, cos abbreviated, right? And of course, you are free to imagine that 1 over sine theta now is just simply flipping this pair. You get hypotenuse over opposite side here. And of course, this is really hypotenuse over opposite side for cosine. Flip this. And the inverse of cos is to flip this. So you get hypotenuse over adjacent side. And the way for inverse of tan is to flip this. That becomes adjacent over opposite side, or the cosine over the sine, okay, of this angle. All right, now, so just a quick one. We need to do this for a while, and let's proceed. All right, so now you are free to imagine. Okay, let me come up here. Now you are free to imagine, okay, an equilateral triangle like so. This is an equilateral triangle, okay, and there are 2 units apart. The sides are 2 units apart, right? And if and of course, equilateral means all the angles, okay, are the same. So if this is a 60-degree angle, this is a 60, this is also a 60-degree angle, right? And of course, when I divide this into, or I bisect this into, or I half it, it turns out to be that this angle now is 30 degree, right? And this angle is also 30 degree, and of course, they sum up to be 60. Now, it means this side is 1 unit, this interval is 1, since every is 2. And of course, okay, I have this 1 unit. So all I'm interested now is, okay, I want to take this right angle, okay, I want to take the side of this, it could be this side or this side, but my goal is this now, okay, I really want to start off with angle 30 to be the acute angle, okay, and of course, on subsequent times, I'll use 60. Now, we call these the basic angles. So, angle 30, 30 degree, 60 degree, and 45 degree, okay, they are basic angles. And of course, you could get a pair of other angles, okay, from just these basic angles here, okay, that even goes beyond 360 degree. All right, so let's look at that in somewhat more detail now. I need to wipe this part off for my convenience. So let's see. Let's see. Okay, I'll do this here. It's fine. All right. So I have I picked this pen now, but this is 30. And this is 60 degree, and this is my 90 degree, right? So I want to fit the vertex of this reference acute angle, which is 30 now, okay, at the center of this circle. So you are free to imagine that this is okay. If I have a 0 degree here, so I could go, okay, I could orient this, okay, to what I call 30 degree angle, okay? So you're just free to imagine this is 30 degree, this is 30 degree, right? So the vertex exactly is 30, is at the center of the circle, that's the 30. And of course, we have something like so, right? And this is right angle here, right? So this side, you are free to imagine to be the opposite side. If you take the reference angle here, and this side, okay, is the adjacent, then you have the hypotenuse side. Now, but please watch this. The hypotenuse side itself is a radius. So this is really meant to be 1 unit, okay? We'll talk more about that, all right, in a moment. All right, so let's proceed now. This is 30, right? So this is 30, from 30 to this side, let me see. from this angle 30 to 90. I don't know what this is yet, okay? But I do know that this side, let me see. I do know that, okay, from 60, let me see, from 60 to the right angle here, this is 1 unit, right? Then from the angle 30, right, from the angle 30, right, to this side, right, that is 2 units, clearly, right? So I could figure out what this is now. How? I could use the Pythagorean theorem. So the Pythagorean theorem is used for finding the sides, okay, of a given right angle triangle. It has to be a right angle triangle. So if you care to look for either of the sides of the right angle triangle, you use the Pythagorean theorem. So the Pythagorean theorem, okay, states that the square on the hypotenuse side, which is, okay, the longest at the slant side, is equal to the sum of the squares of the other 2 sides, okay? So you are free to call one side opposite, take the square of it, plus, okay, the other side, you are free to call that, okay, the adjacent side. Alright, so the adjacent side here is a 2, right? So this is the opposite side, and I'm looking for the adjacent side, right? So I could pick this pair now. I have, okay, let me stick in the values first. Opposite is 2 raised to power 2, and hypotenuse is 2, it's carrying power 2, opposite is 1, raised to power 2, then I don't really know what the adjacent side is, okay? And you are free to call this x. It's carrying the power 2. So now I pick this pair, right? Okay, I could pick this pair now. That's the right hand side, which is 1 raised to power 2 plus x squared, is the same as, okay, the left hand side, which is 2 raised to power 2. So I'm interested in knowing what x, which is the adjacent side, is this side. So x squared now becomes 2 squared, and I could transpose this, the plus, and it becomes a minus 1 raised to power 2 here. Now this is really, I could perceive the smell of difference of 2 squared here. The case where you have x is carrying the power 2, y is carrying the power 2, and there is a minus in between it, just like you have this term is carrying power 2, 1 is carrying power 2. So it turns out to be, you just open 2 brackets, stick in 2 brackets, sticking an x and y in one, x and y in the second, sticking a plus in between them, okay, and a minus in between. So it turns out to be that the adjacent side becomes, okay, something like so. I have a 2 and a 1, just like you have your x and y, 2 and a 1, so I have a plus and I have a minus. So x squared is 2 plus 1 is a 3, 2 minus 1 is a 1, and 3 times 1, right, is still a 3. So I could delete now the square. So x is carrying power 2, this is equal to 3. Now, 2 times a half, right, gives me a 1. So if I take this to power half itself is the same as taking the square root, okay, of a term. So if I take the square root of this, is as good as saying, okay, plus or minus, is as good as saying, okay, I took x raised to power 2 now, okay, to power half, right? So clearly, can you see 2 times 1 from the law of indices? Okay, a term is carrying a power, still carrying another power, so the powers will multiply out. So you see 2 times the half, I lose the 2, I'm left with x raised to power 1, which is the same as x, right? And of course, I'm trying to getting the positive part of it, and that is just, okay, the root 3. So x, which is the adjacent side, is just root 3. So the adjacent side is, okay, root 3. Alright, so let's proceed. You may bring this for a while, okay, I'm going to clean this up. Alright, so I'm not interested, okay, in knowing what's the sine, the cosine, the tangent, okay, the cosec, secant, and cotangent, okay, of this 30-degree angle and 60-degree angles, okay. At subsequent time, I'll talk about 40. Of course, I'll go to 360, and of course, we'll go beyond that. Alright, can I clean up? Alright, so I'm going to beam this for a while. Okay, alright. So let's proceed now. So I will need to rewrite this. Alright. So let me write out the 3 basic, okay, 3 ratios, right? We have sine, we have the cosine, and we have the tangent, right? And of course you could have the other 3, okay? Sine is really the ratio of the opposite to hypotenuse side, right? And the opposite side here, if you look at the unit circle, is really the y-axis, right? So the opposite here over hypotenuse. The opposite here is really the y-axis. And the hypotenuse itself here represents the radius, right, of that circle. So this is really the radius. So you are free to imagine this to be your y, the vertical axis, and imagine, okay, free to imagine this to be x. So the hypotenuse side is really the r, okay? Then the cosine is adjacent side, that's adjacent, okay, car over hypotenuse side. This is x over r. Then the tangent is really the TOA, the opposite side over the adjacent side. And opposite is y. You are free to imagine this, okay, to be y axis. Then adjacent is the x, right? Now let's see. The radius is 1 in the unit circle. So all I need to do is just to make the radius 1 here. So how do I make the radius 1? I could divide both sides, all sides of the triangle by 2, the right angle triangle by 2. So it turns out to be that once I do that, right, I get a 1 from the radius. So this turns out to be y, and of course the radius is just the 1 here, and of course that is just the y. So you are free to imagine sine theta to be y, and of course the cosine is x, the radius is 1 here. You are free to imagine cosine to be just the x axis. Then the tangent, I have a y, okay, just okay, y over x, alright, and that's it. Alright, so let's talk about the sine now, okay, and the cosine, okay, and the tangent of just the 30-degree angle, okay, and for the sake of time, I will talk, okay, about the other basic angles, okay, in a subsequent bulletin. Alright, so let's proceed. Now, let me define some coordinates here now from 0. So I have a 0, this is 30, okay, you are free to, okay, my this is 60, okay, this is 90, this is 90 degree, this is, okay, 120, this is, okay, 150, do not draw to scale, okay, you are free to imagine this is 180 degree, okay, both 30 degree angle more, you have a 210 here, okay, 30 degree more, you have a 240, this is 270, okay, this is 300, this is 330, of course this is 0, or you have a 360 degree, okay, or 0. Now, the coordinates, look at it, xy here, this is 360 or 0. The coordinate here, that is, if we're taking the list here, xy, x is cosine, y is sine. So the coordinate here is x is 1 here, you could see it's 1 unit. So x is 1 here, but y is a 0 here, right? Y is a 0 here. Then we come here, if we take the coordinate now here, we see that x is 0 here, but y is what is plus 1. This is the positive, okay, y-axis. Then we come here, x is really a 1 here, but y is a 0 here, but x is negative here, so we stick in the minus here, right? Then we come here, x is a 0 here, but y is 1, but it's negative 1 because this is the minus y-axis. Of course, now I'm going to wrap this up, okay, for the sake of time. When next we meet, we'll continue. Thank you.